Well, hello again. I'm glad to see you back. In this video, we're going to look at the acid-catalyzed aldol reaction. Now, in our previous video, you may recall we looked at the base-catalyzed reaction. And we're gonna actually look at the same reaction in our kind of same reactants and same product, but we're gonna look at a slightly different way to get there. So we're gonna react acetaldehyde with itself again to make this aldol product, this beta hydroxyaldehyde. Only we're gonna use H3O plus and water to accomplish that goal instead of sodium hydroxide and water. So this video is really for you out there in the listening audience that loves proton transfers. Okay, this is for you. This is your day. And by the way, I just saw that I got a maybe my first subscriber. Okay, and I just thank you for your support. I really appreciate that. If you like this video, don't forget to smash the like button. And if you don't like the video, please also smash the like button. I learned that from a fellow YouTuber. All right. Okay, so let's look at the mechanism of this reaction. Now, in the base catalyzed version, the enolate was acting as our nucleophile. In the acid catalyzed version, an enol is going to act as a nucleophile. Okay, and so our first step here is going to be a proton transfer. Now, in the base catalyzed version, we had a proton transfer as our first step, but it was removing a hydrogen. Here we're protonating that oxygen. Plus charge on that oxygen. Okay, and again, everything's under equilibrium here. And let's see here, can I squeeze this in? We're gonna have a second proton transfer. And that's going to make this. Okay, so this is my enol. It has two resonance forms. Okay, if you recall, we call it an enol because it's got the CC double bond, so that we see in alkenes, and it's also an alcohol. All right, so we took 2 steps to get to there, 2 proton transfers. And the next thing that's going to happen is this is going to react with our other molecule of our aldehyde. All right. Oh, and actually, we protonated an aldehyde up here, so we're going to use the protonated form of the aldehyde as the electrophile. Okay. If I use the non-protonated form, I would have a negative charge on the oxygen, and I want to avoid doing that under acid catalyzed conditions. Okay. So we're going to do a nucleophilic addition. Okay, and I'm going to run out of room here, but that's okay. I'll just erase a few things. Okay, so when I do that, here. So here's my carbon, the alpha carbon that acted as a nucleophile. There's my new bond. OH. Okay. Now I'm almost to my final product. I don't want to leave this in its protonated form, so I'm going to do a deprotonation. So I'll make a little room up here to do that. And I'm going to take my water. I'm going to do a proton transfer. PT. And that's going to make this, which is, ooh, I need to slow down here, slow down, a beta hydroxy, so alpha, beta hydroxy aldehyde. Okay, so overall, my mechanistic steps in the acid catalyzed aldol reaction were proton transfer, nucleophilic addition, and then a final proton transfer. The first two proton transfers tautomerized us from the keto form to the enol form, and then we did our nucleophilic attack and other proton transfer. Let's look at one more example of this. And up to this point, I have been using aldehydes, okay? But I think just for fun, I'll show you doing this with a ketone, okay? What kind of ketone should I use? Let's use this ketone. Okay, so we're gonna have that reacting with itself. Okay. H3O plus, H2O. Okay. And again, the key to this reaction is we're going to have the alpha carbon, so carbonyl carbon, alpha carbon on one of these is going to react with the carbonyl carbon on the other one. All right. And okay. Yeah, actually, let me put that in green. I'm going to highlight my new CC bond here. There it is. Okay, we got a hydrogen coming off of here. OH. Okay, see that connection there? So this carbon, maybe I'll circle these here. So this was our alpha carbon, there was our carbonyl carbon. Okay. Boy, and I've got an alpha beta hydroxy alcohol. All right, so that is going to conclude our video on the acid catalyzed version of the aldol reaction. In the next video, I'm going to talk about what happens when we heat. We use conditions where we add heat, because what that's going to do is we're going to have a dehydration. It's going to go ahead and dehydrate. We're going to lose a molecule of water, and so we'll look at that in the next video. All right, thanks for watching.